Hello class. Unit 9 is Intermediate Syntax 1, and in this unit your programming assignment and quiz will be due on 11/1, so you have a little time here. This is chapter 18, so we're moving around a little bit in our text, not moving exactly in order. This chapter has to do with recursion. Your assignment is sum the digits, and it is a recursion type activity. You also have a discussion board and a quiz. Let's take a little look at recursion. You have some great information in Ravel, and it will help you, of course, if you look at Ravel closely. Recursion is a common processing pattern, and what it does is allow us to recursively explore a calculation or process. That'll make more sense here in a second. When you're looking at your textbook or Ravel, be thinking about answering these questions. What is infinite recursion? What is direct recursion? What is indirect recursion? What do we mean when we refer to the base case? Your Ravel information does a great job of explaining the recursion issue in these technical terms. Now, when we're working with a recursive method, we can also have a recursive helper method. And in your textbook, if you're taking a look at that, you'll see that a helper method is basically a second method that accepts additional parameters from our original method. So we're shrinking the size of the problem. In your textbook, you'll see that the is palindrome method is used, and it's defined to take an argument or a parameter of a string. Its helper method, is palindrome, takes a parameter of a string, but also a beginning integer point and an ending integer point in that string, so that we can test smaller and smaller sections of the string. Let's talk about what recursion actually is. Been telling you a little bit about looking in your text and making sure that you're understanding things. But a really good example of a recursive instance is a directory in Windows or in Linux, any operating system. But we start with the root directory of our hard drive, and then as we zoom or work our way, drill down from folder to folder to folder, we're recursively going through those folders looking to see what's down deeper and deeper inside of the folder structure. In your textbook in Ravel, listing 18.7 is an awesome example of a directory size program. It actually lets you drill down through your Windows directory structure and accumulate the size of all of the files and folders in a given directory as an example of a recursive program. So this is a great activity for you to create on your own, as well as going through the case study in the book. The Tower of Hanoi is another case study in your textbook, and this is a game that's being played in the Tower of Hanoi algorithm. As you look at this game, please think about how this algorithm could apply to other constructs you might encounter. It's a very important algorithm idea. Fractals also give us some great implementations of recursive code. If you look at the fractals case study in your text and in Ravel, you'll see some interesting geometric patterns. But if you explore YouTube and look at some of the animated fractals, you'll see some really beautiful patterns being created. And you'll see also there's so many interesting fractal applications that have to do with scientific research. So this is a really important topic. Let's take a quick look at this video about the Fibonacci sequence. Now, the Fibonacci sequence is one of the items that's presented to you in your textbook as an implementation of a recursive problem. It can be a little bit overwhelming, but let's take a quick look at this video together.
Let's suppose that you're writing a really important email to a colleague.
There we go. It's short. I won't play the whole thing. I'll stop there. But you see that the link is in the presentation, and I'll put this on Blackboard for you. So notice how these recursive patterns can be used to apply patterns and designs to nature and to create patterns that we see often. So that's why these mathematical concepts are very important to you. Now, sometimes again, with looking at all the different mathematical implementations that are used as examples for recursive methods, it can be kind of hard to understand a real-world application. And one real-world application that we see of recursiveness, or recursion more properly, is a bill of materials structure. Here we have a bill of materials structure for a bicycle. The bicycle is built of many parts, and one of the parts we get is a pre-assembled frame and fork. Now we know that that part is made of many other parts also. We also have some handlebar assemblies, different things. So be thinking, what is a bill of materials? It's a list of all of the parts we need to create some sort of product. Oftentimes, our bill of materials list can be quite involved and very long, as in this example, to create this beautiful shoe. So we have to have many different pieces and parts. And when we create this structure within a system to keep track of information, we're going to have relationships with products to other products. So for example, if we want to find all of the pieces and parts we need to build this shoe, we might call some sort of method like get product, passing a product ID integer in. And in that method, the method may test to see if this product is built from other products, and if so, go ahead and call itself again using a get product, this time passing an integer of one of the subproduct IDs, so that we can recursively go throughout our product database and find all of the pieces and parts that we need to build a product, a complete product, or a subassembly depending on what we're doing. So that bill of materials structure gives us a real-world business application of a recursive relationship that we might have to implement in our code. So be sure you use your resources for this chapter. Be thinking, what is recursion versus iteration? Which is more resource intensive? And if you're concerned about resources, which should you use? Be sure you're ready to answer these questions. Okay, that's about it for this chapter. I think that you'll find the information for your assignment should make it pretty clear. It should be much more approachable than some of the assignments you've had to do recently that have been really involved. You've done a great job. Keep up the good work, and let me know if you have any questions.